Okay, so today let's talk about how we can simplify IBC testing, IBC scripting, and in general IBC analysis using Orchestrator. And we will do so by example. So here I'm presenting the ICA implementation in CosmWasm done by Confio. You can find the link in the description. And this ICA contract application has two main contracts: the host, which is responsible for executing on a remote chain, and the controller, who is responsible for passing messages from a local chain to the remote chain. So here we will present Orchestrator very quickly and focus on the interchain features that it provides. So the first step in our execution is to deploy the contracts. So let's see this function here, which is responsible for uploading and instantiating the contracts. So you see the syntax is really easy. It's what we're used to with Orchestrator. Easy syntax to interact with our contract structures. So once those contracts are deployed, and here keep in mind that we are in any environment. It can be a daemon environment, so that means interacting with RPCs, actual Cosmos nodes, or test nodes, or even local nodes. But this can also be used in a totally local test environment based on CW multi-tests. So for doing things really locally. So basically, it's really useful for testing when developing your application. So the first step is deploying the contracts. That's done. Then we need to create a contract channel between the host and the controller. So that's simply an ABC channel between two contracts. That's what we do here using this interchain object. We will come back later on this object. It's at the center of the IBC features that Orchestrator provides. So here we create the channel. Behind the scenes, it can either create an actual channel using a relayer, or it can create a channel in our mock environment, or it can simply await for you to execute your channel creation outside of the program. Then, when the channel is created, this function returns, and we can get to the actual ICA test. So in this function here. And in this function, we have some queries to make sure everything is in place. And finally, we do here, in this function, the actual ICA interaction. We want to burn some funds on the host chain, on the remote chain. And this burn response is actually only the transaction response from executing a transaction on the controller, so on the local chain. And then what Orchestrator provides is this wait IBC function, which from this transaction will query all IBC packets that have been sent out. It will await the relaying of all those packets and then return when all of this is done. Keep in mind that this function can also find if the packet has timed out. So it's not only about awaiting a successful broadcast, it's also awaiting timeouts, which is error packet relaying. So yeah, you get the gist of the application. Now let's see it in action in two different environments. So the first environment is our test environment. So here I'm running a simple test, and you see that just after compilation, this test will be run really smoothly, really fast, and all this test happens inside the Rust code. So you see that we upload the different codes, we instantiate our contracts, then we create a channel. This channel creates IBC packets to identify chains. So this is how the ICA works. This IBC packet gets relayed, really simple. Then we execute this burn message that has to be sent via this number 2 packet on the remote chain. This number 2 packet is caught by the relayer, which relays between Osmosis and Juno. So you see this execution was really fast and is really simple to execute such a function inside a test environment. Now we will do the same thing, but with actual nodes. So this is the result. But with actual nodes, it looks like this. So here you see that we're using Starship, which is a local setup to create mini Cosmos environments with chains and relays between them. So you see that we're actually interacting with local RPC endpoints. So here we have Stargaze at this RPC endpoint and Juno. So we're doing the exact same thing, but instead of a local test environment, which was really quick to run because everything was code, no API, nothing. Here we're interacting with actual blockchain APIs. So uploading took some time. Instantiating took a little bit more time also. Now we created the channel. So the Starship also provides relayers. So it's really simple using Orchestrator to create channels between contracts, create connections. Everything is really straightforward. It's all in the same code that I've shown you at the beginning of this video. Here we created channel. You see that it reports all the transaction hashes along the way. So that's really good also for debugging. You can see all those transactions are related to this channel creation. Then, just as before, it picks up this IBC packet number 1, which is an IBC packet sent out during channel creation on ICA contracts. And now we're waiting for the relayer to actually relay the packet. It's a bit longer because the relayer, the Hermes relayer that works with Starship, waits 1 minute between when it's idle. So when it's idle, it just waits 1 minute and then looks back for IBC packets to relay. So we just wait. Now it's done. You see the packet here has been received on the chain using on this transaction hash, and then the acknowledgement was sent back on Stargaze and now received on Stargaze with this transaction hash. So here we've followed the whole IBC packet run just using gRPC queries, so querying for the packet to be received and then acknowledged back on the sending chain. And the second message is sent here as before. We're burning some Juno from a Stargaze, and so in the same thing, we have this transaction hash. We analyze what's happening in this transaction hash, which is we sent an IBC packet, so with sequence number 2. So you see the packet here, and just as before, we're waiting for the relayer to transmit the packet. The packet has been received on Juno on this transaction. We see the acknowledgement here. And now the acknowledgement has been received on the sending chain and the script exits. So what this provides is simple tooling for you to await all your IBC execution without having to do a lot of scripts or a lot of parts in your deployment or your scripting. It's just you have one file, you execute your script, you execute your IBC interaction, you wait them, and then you're good to go.